I'm Anil Kumar, and in this video we will understand how to find solution of an inequality from the given graph, right? So in this particular video we will solve for f of x greater than g of x, okay? We are given graph of both the functions. F of x is a parabola which opens downwards, this is the one, and g of x is a straight line. Now can you write down the solution for f of x greater than g of x? So it's a linear quadratic system, and we are looking for a solution of f of x greater than g of x, where f of x is the parabola and g of x is a line as shown in the graph. So you can pause the video, answer this question, and then share with my solution. Okay. Now from the graph, what we really do is, for each value of x, we compare y values. Now if we want f of x greater than g of x, then in the interval wherever fx values are higher than g of x will be part of our solution. Remember one thing, that when you're talking about inequalities, we will have a range or an interval as a solution, right? It's not just few points, right? So here our interval is this portion where f of x is greater than g of x. Do you see that? And if you see the x values, that is one, this is the other one, then the interval between 0 to this, which is happens to be 3, is the solution, correct? So that is how we get the solution from a graph. So we'll say f of x is greater than g of x implies from the graph that x is greater than 0 and is less than 3. You could also write this in another notation, which is between 0 and 3, right? So either way you can write down your solution. Okay, so that's easy. Now the second part of the question which we are actually going to do here is to find algebraic solution. Now my question is, write down the equations of the given graph and solve it algebraically. Algebraic solution for f of x greater than g of x, right? So now you can pause the video and then solve it and look into my suggestion. So let's begin by finding the equations for both the curves. First with f of x. It's a parabola opens downwards, that means negative leading coefficient. Vertex is at 2 and 4, so it is x minus 2 whole square plus 4, and the leading coefficient is, if I move one unit to right, I move one down, right? And then second unit 3 down, that means a is 1, so it is 1. Therefore f of x for me is minus x minus 2 whole square plus 4. I can always open this bracket, right, and write it in some other form, which is standard form. So let me open this bracket and write this as, we can write this as x squared minus 4x, negative outside, right, plus 4 plus 4. So when I open the bracket, I get minus x squared plus 4x minus 4, and this is plus 4, so which is same as minus x squared plus 4x. So that is in standard form my function f of x. Now let us find equation for g of x. So g of x is a straight line. We can take any 2 points. One point is origin, so y-intercept is 0. We need to find slope. Let's take another point. So the other point is 3, 3. Slope is 3 divided by 3, which is 1. So I can write g of x as equals to x. So these are my two functions. Now if I have to solve for f of x greater than g of x, I can also solve for f of x minus g of x greater than 0, right? Both are same thing. So when we are solving for f of x greater than g of x, we could also solve for f of x minus g of x equals to 0, okay? So that becomes simpler. We'll bring everything to one side and then solve, okay? So we'll actually solve this time for f of x minus g of x greater than 0. As you can see, it means the same thing, right? So let's solve. F of x is minus x squared plus 4x. G of x is x, so we'll do minus x greater than 0. Let's combine these terms. minus x squared plus 3x is greater than 0. Now here we can factor, so we get minus x, x minus 3 greater than 0. Now we have inequality in this form. So if I have to solve this inequality, what can I do? You can actually you can solve it in now two different ways. We are looking for minus x times x minus 3 greater than 0. So we can make table of values, right? So in that case, let me make table of values here for different intervals. So what I'm trying to say here is that, let me make table of values and then I'll show you my solution. Okay, let's push it upwards since I don't have much space here. Okay, so we have two zeros here. So the zeros are at let us say the 0 is at 0 and at 3. So the zeros are at 0 and 3. Now these zeros divide our plane into three intervals. One is from minus infinity to 0. The other one is from 0 to 3. And then we have from 3 to infinity. Let's take test points in each interval. Let's take test points in each interval. So in this interval, let me take a test point as minus 1. Here 1. And here let's take 4. And then we'll test our factors. So if I write these factors as minus x and x minus 3, then if it is minus 1, this becomes positive. For 1, this will be negative. And this will be negative for 4, negative 4. If I substitute this in the second factor, I get negative, negative, and positive. When I multiply these two, what do I get? Do I get negative or positive result? That decides. So when I multiply these two, I get negative. Here, it gets positive, and in this case, negative. Therefore, in the interval 0 to 3, f of x is greater than g of x. Correct? So we get our solution that f of x is greater than g of x when x is between 0 and 3. Correct? So the same answer as is shown in the graph. At times, what you can also do is you can sketch. It is negative between x and two zeros. So you can sketch your graph. If you sketch your graph, it will be kind of like this, a parabola, which is positive here. So that is your answer. So you don't have to do the interval method. Graphically, at this stage also, you can do it. Correct? So that is how you can actually solve this particular question. I hope that helps. Thank you and all the best.